Hello everyone, my name is Siddharth. I'm an alumnus from IISER Trivandrum, and today we'll be solving a question that appeared in the IISER entrance exam in the year 2020. So you have been given a triangular wedge which is an isosceles triangle because both the angles at the base are equal, and there is a pulley at the apex which has a string passing over it connected to two masses, and there is friction everywhere in the system. All the values are given symbolically. Now when you've been given a symbolic question like this where not even a single number is present, the first thing to understand is you are in for a long derivation. Be prepared to write a lot of steps, write clearly, and don't miss out on any calculation step, because if you do, you might end up making a very critical mistake at that point which will ruin your entire answer. So let us just first write down everything that this system can tell us. We have been asked the ratio m1 upon m2 such that the whole system is in equilibrium, which is good because that just means we have to balance forces on each and every object in the question, and we'll be done for. So let us first draw the forces that are acting on the two blocks. Of course, their individual weights will be acting vertically downwards. Here's m2g and here's m1 into g. And since there is a wedge, it will exert normal reaction forces on both of them. Let's call this force as N2 and let's call this force as N1. Now we've been given that the mass M1 is greater than the mass M2. So M1 will move in the downwards direction and M2 will move in the upwards direction, which means M1 will experience a frictional force opposite to its motion, that is upwards along the incline. Let's call this force as friction force 1, and M2 will experience a frictional force downwards along the incline F2. Of course, there will be tension in the string which will be common for both the objects. So now that we have the force diagrams for both the objects, we can start with balancing them. Now we'll balance the forces in the perpendicular direction to the incline and the horizontal direction to the incline, because that is much easier since we have only one force to resolve. We know that the normal reaction force balances the cos component of the weight. So let us write down the values of N1 and N2 both. N1 will be equal to M1 into G cos theta, and N2 will be equal to M2 into G cos theta. Since it's an isosceles triangle, theta is equal for both the objects. Now let us get to balancing the forces along the incline direction. For the first object, it will experience the sine component of its weight downwards along the incline, which will be balanced by the tension force as well as the friction force. And we know the value of friction force in limiting case is equal to mu1 into n1. Since we know the value of n1, we can just substitute over here. Expanding all of this, we get m1 into g sine theta should be balanced by the tension plus mu1 into normal reaction force, that is m1 into g cos theta. Similarly, balancing forces on m2, we get m2 into g sin theta should be balanced by the tension, and this time since the friction force is acting downwards, we will minus m2 into m2g cos theta. Now we don't know the value of tension, and that is not even relevant to what quantity we are trying to calculate. So we need to first eliminate T from both of these equations. Let's call this equation 1, let's call this equation 2, and we can see that if we just simply subtract 2 from equation 1, T will get cancelled from both the sides. So let's just write down that expression. M1g sin theta minus M2g sin theta will be left. Let's write down here m1 into g into sin theta minus m2 into g to sin theta. T will get cancelled, and what will be left is the friction forces on both the objects. M1g cos theta plus mu2 into m2 into g cos theta. So this is the equation that we are left with after subtracting equation 2 from equation 1. Now since we require the ratio m1 upon m2, we need to get this quantity in our equation, which can be achieved simply by dividing the entire equation by m2. Let's divide m2 in all the terms. Now in terms where there's only m2 present, it will get cancelled happily, and in terms where there's m1 present, we will end up with the ratio that we have. Now if we simply rearrange these terms so that all the terms containing m1 and m2 are in the LHS and all the terms containing only sin theta and g are in the RHS, we will be left with m1 upon m2 should be multiplied by g sin theta minus of mu1 g cos theta, g sin theta minus mu1 into g cos theta. This will be equal to, we have mu2 into g cos theta in this case, mu2 into g cos theta, and we'll add g sin theta to it. So simply we will divide this bracket on the RHS and will be end up with m1 upon m2 is equal to mu2 into g cos theta plus g sin theta upon g sin theta minus mu1 g cos theta. Cancelling g from all the sides, we can see that option C is the correct answer to this question. Thank you for watching this video and subscribe to our channel for more such content.